Section 5.5 is the trapezoid rule. If you remember, this is another way to approximate area under a curve. So the trapezoidal approximations, we're going to add up all of these trapezoids. Each trapezoid has the equation 1/2 the height times b sub 1 plus b sub 2. That's our regular area of a trapezoid. For our purposes, the height is the width of the interval, or the dx, and our b sub 1 and b sub 2 are our y values. Oh, I am having trouble again. There we go. So here it is set up. They've got the height every time, and then you can see that they factor that out to the front. We've got our first y sub 0 plus y sub 1, and then divided by 2, y sub 1, y sub 2, divided by 2, etc., etc. When it all gets done, since I have this half of a y sub 1 and this half of a y sub 1, it ends up being just y sub 1, if you consolidate this equation. And then by pulling out the 2, we can just use y, 2y1, 2y2, etc. until we get to y sub n. So this is the formula we're going to be using for our trapezoid approximations. We're also going to talk about something, here it is. So here's the formula that we're going to use, where AB is partitioned into n subintervals of equal length. H equals B minus A over N. And so this is the left rem plus the right rem divided by 2. So you can find the Riemann sums first and find the trapezoid approximation by taking the average. Okay, error bounds. We are not going to be using Simpson's rule, so we do not need the Simpson's rule error bound. But if T represents an approximation using the trapezoid rule, then the errors, so we're just going to write, if T represents the approximation of this given by the trapezoid rule, then the error E sub T satisfies this equation. So the error is the difference between the actual area and what we get from the trapezoid rule. So this means, see if I have a slide that explains this in more detail, or whether I should just go ahead. So this means that the error, plus or minus, we're just looking for the absolute value error, I don't care if it's smaller or bigger, is always less than or equal to the distance of the interval, b minus a, divided by 12 times h squared. Remember, h is the width of each interval. And this means the maximum value of f double prime. Maximum value of f double prime. And that will give us an approximation for how far off we are. Okay, so let's do one. Use the trapezoid rule with n equals 4 to approximate the value. So the first thing we're going to do is use our trapezoid rule. So I'm going to take 1/2 of h, in this case 0 to 2, divided into 4 approximations, each one is 1/2, times my first y value, f of 0, plus 2 times f of 1/2, plus 2 times f of 1, plus 2 times f of 3/2, plus f of 2. Since my function is to square this value, I now have 1/4 times 0 squared is 0. 2 times 1/2 squared is 1/4. 1 squared is 1. 3/2 squared is 9/4. And just square the 2. So I now have 1/4 of 1/2 plus 2 plus 9/2 plus 4. And if I do all of that, I will get 11/4, or 2 3/4. Okay, so that's my trapezoidal approximation. Let's look at our error. The error of our trapezoidal approximation to the actual has to be less than or equal to my interval 2 minus 0 divided by 12 times my h value, my dx, times the maximum value of f double prime. So let's find f double prime. F prime is 2x, f double prime is 2. So the maximum value of that is 2 twelfths times 1/2 times 2. So my error is less than or equal to 1/6. So that's if I want an approximation. If I want to know how close is this value of 2 3/4, I know that it is plus or minus 1/6 on either side. Now, if I actually integrate this using either my calculator or using an antiderivative, which you know how to do, we will get that the actual value of the integral is actually 8/3. Okay? So the actual interval is 8/3. That's a difference from my 2 3/4 minus my 8/3 is a difference of, so my actual error is going to be 0.08333. My error bound approximation, is 0.1666. And so my actual error is less than my approximation. The approximation is always going to be off, but at least I know whether I am close or not. So error bound is a new topic that we've introduced, and that's the end of this video. Most of our work will be just using the trapezoid rule. So again, the textbook in their PowerPoints offers, sorry, I can't get rid of that, offers a quick quiz. So I'm going to, again, just scroll through this. On the quiz, the answers come up every other screen. So at some point, if you want to go back and take this quick quiz, it will be here at the end of the video for you. I'm just going to scroll through. There's the answer. Sorry. Okay, and then here's a chapter test. I wish I could get rid of this, but I can't. See if it'll work this way. Nope. Ah, there we go. Perfect. So chapter test, again, it's going to go through all the questions and then put the answers at the end. So I'll scroll through in case you want to use this later as a review tool. And then here come the solutions. So that's it.